Now my next question is, AB belongs to R and f function real number to real number be defined fx is equal to a cos modulus x cube minus x and plus b modulus x sine again modulus x cube plus x. So differentiable at x is equal to 0 if a is equal to 0 and b equal to 1. Differentiable at x is equal to 1 if a is equal to 1 and b is equal to 0. Not differentiable at x is equal to 0 if a is equal to 0 and b is equal to 0. Not differentiable at x is equal to 1 if a is equal to 1 and b is equal to 1. So first case, that is, let me take the first case. That is, if your a is equal to 0 and b is equal to 1. So here a is 0, so b 1, your function will be fx, that will be modulus x sine modulus x cube plus x, this one. So now we have to test the differentiability at x is equal to 0. So your left hand derivative, that is f dash 0, this will be limit h tends to 0 f 0 minus h minus f 0 divided by h. So here 0 minus h, that is limit h tends to 0, 0 minus h, that is 0 minus h. Now sine modulus 0 minus h the whole cube, and this is modulus whole cube plus 0 minus h. Now f0 is 0 and divided by, this is minus 0 divided by h. So here you see limit h tends to 0 minus h, this cancels out, and if you place this is 0, so sine 0 is 0, so this is so this will be your answer will be 0, because here you see plus h cancel out. Let me write a line for it. Limit h tends to 0, so this is h and this is sine minus h the whole cube plus plus this and the modulus, that is equal to limit h tends to 0, this is h, and sine this is how much, minus h the whole cube and minus h by h, this h cancels out, and when this is sine 0, this is equal to 0. Now let me take right hand derivative. Your right hand derivative will be your f dash 0, that is equal to limit h tends to 0 f 0 plus h minus f 0 by h. So now again this will be limit h tends to 0, this is what is 0 plus h, and sine this will be 0 plus h the whole modulus 0 plus h the whole cube plus 0 plus h by h. Same thing here, h cancels out, and here 0, your sine 0 will be how much, 0, so answer will be 0. So your this first is correct, at x is equal, it is differentiable at x is equal to 0. Now my next case is, this is correct. So for next case is, that is here your next case is that is if a is equal to 1 and b is equal to 0. So a is equal to 1, b is equal to 0, so your function is fx is equal to cos modulus x cube minus x. So at x is equal to 1, I have to test the derivative. So this will be f dash 1 left hand derivative, f dash 1 left or right or whatever you take, it is up to you, have to take both the thing. Your right hand derivative, this will be limit h tends to 0, h tends to 0, so this will be cos modulus 0 plus h the whole cube, this is h, 0 plus h the whole cube minus 0 plus h, and then f0 cos 0 is 1 minus 1 divided by your h, because your formula is fx plus h minus fx by h. This is your for right hand derivative, this is your formula, right hand derivative. So here you are going to get limit h tends to 0 cos, this will be h cube, oh sorry, I have tested in 1, so this will be 1 plus, and this is 1 plus h. So this is because I am testing at x is equal to 1, I am testing the derivative at x is equal to 1, so it will be 1 plus h. Earlier it was at 0, so it was 0 plus h. So here it is 1 plus h, so 1 cube plus 3a square b plus 3ab square plus h cube minus 1 minus h close minus 1 by h. Here you see this minus minus cancels out, so this will be limit h tends to 0 cos, this will be this cancels out, so this will be 2h plus 3h square plus h cube minus 1 by h. So here cos 0 will be 1, 1 minus 1 0, 0 by 0, again it is in the form 0 by 0. So I will go for L'Hospital rule, your L'Hospital rule, I will go for L'Hospital rule. In this L'Hospital rule you will differentiate this numerator as well as you will differentiate the denominator. So when you limit your h tends to 0, so when you differentiate this, you are going to get differentiation of this is minus sine 2h plus 3h square plus h cube, this will be chain rule, we are going to chain rule, and into this will be 2 plus 6h plus 3h square, and this is 0 by 1. So now here you see that h is 0, so for h is 0, this becomes 0, and 0 into anything is 0, so your answer is 0 here, your answer is 0. Now similarly I have to go for left hand derivative, this is your right hand derivative. Now I have to go for left hand derivative. Now for left hand derivative same, it will left hand derivative, it will be same, that is f dash 1 limit your h tends to 0 cos 1 minus h the whole cube minus 1 minus h, and then one thing that is here 1 minus 1, this will be 0, so cos 0 is 1, so this is minus 1 divided by minus h. Here you see this is 1, so for 1 fx means f1, so 1 minus 1 0, cos 0 is 1. So now I will get the same result. Here you see instead of here it will be 1 minus 3h and then plus 3h square minus h cube minus 1 plus h, this minus minus cancels out, and this will be minus 2h. Again I will have to apply L'Hospital rule, I will get the same, and your answer will be 0. You can check it, your answer will be 0. So here also at x is equal to 1 it is differentiable, so your these two options are correct. So these two options are your correct.